Okay, let's try to solve this problem from chapter 23, that's electric forces. The problem number is 73. So these two, 73 and 74 problems are kind of paired. We will solve 74 later. Let's try to solve this problem 73. So the configuration is given as two positively charged particles are on x-axis, one is on the negative x-axis and another is on the positive x-axis, and the distance between these two charges from the origin is same, and we have to calculate the expression for the net electric force on the third particle, which is on y-axis somewhere here, and it is positively charged, and the distance from this charge from the origin is h, just kind of height. So again, we will obviously use the Coulomb's force F, that is some constant K, times the product of two charges Q1 and Q2 and the distance between them and the square of that. So it's a inverse square force. So here we can see that the symmetry is playing a role that will cancel the component x component of two forces. Okay, so there is a symmetry on x-axis, so we just need to calculate the force, the component of force along y-axis, which is kind of easy. I resolve the forces F1 and F2 like this. Okay, so the angle is theta, this angle, this angle, this angle same, this angle is same. So this is y-axis, the charge is here. So then the total force along the y component of the force Fy can be solved like this: F1 cos theta, okay, plus F2 cos theta. I think you are kind of expert on how to resolve this kind of forces and corresponding axis. So F1 is nothing but just some constant K, again the Coulomb's law, the constant K, and the charge, this charge Q and the another charge small q, two charge, the product of two charges and square of the distance between them. So it's kind of r here, so r is square, again same cos theta. Similarly for F2 as well, the same k times q, uppercase q times lowercase q over r square cos theta. So the cos theta is common here. So you can further express this figure as like this, and you will be able to calculate the value of cos theta. The value of cos theta is the hypotenuse over the ratio of cos theta is the base, the side is adjacent to this theta, to the hypotenuse. So it will be just h over h square plus a square. Okay, so you can just use this value here, and you can further write this r square, which is nothing but this one, and r square is just h square plus a square. When you use that, you can solve or combine these two, h square plus a square. So here the power is 1 over 2 and plus 1, So that will be 1 over 2 plus 1, that will be 3 over 2. So that's it. So this is the force, this is the amount of force along y-axis. That's why you can write J. Okay, so this is how you can solve the net electric force on the third particle with charge q, which is along y-axis. The direction of force is along that. So for part B, we need to solve that the two charges q, these two charges, and on one on the negative x-axis and another on the positive x-axis, behave like a single charge to q located at the origin when the distance h is much greater than a. So we have to show that these two charges, like one on here is similar to if that charge, both the charges are located at here and another charge is here, and the force between them is nothing like the single charge to q instead of charge q and q on the two sides of the origin. So we have to show that. So if S is very very large than A, so this distance has to be very very greater than these two distances A. Okay, so that's the condition. So it's kind of easy. If H is very very large than A, so the denominator, that is h square plus a square to the power 3 by 2, can be written as h square power 3 by 2, because in comparison to h, a will be very very less and can be neglected. Okay, so you will just end up getting h square, and you will just have to solve very simple mathematics, and we can reconfigure that this constant k times 2q here, 2 and q times q. This is like another charge q2, this is like charge q1, and this is like charge, it's like k times q1 q2 over r square. Okay, it's like r square. So this is the distance between these two charges. H is the distance between these two charges. Okay, so that is nothing but just the two charges q behave like a single charge 2q located at the origin when h is very very large than a. So it's kind of interesting problem which you can solve easily. Thank you.